Our universe is a theater of unimaginable violence and beauty. Stars exist so vast they could gulp down our entire solar system without a trace, while distant worlds are lashed by perpetual storms of molten glass. This is the realm of extreme environments, places where the laws of physics are pushed to their absolute limits. We are embarking on a tour of 28 of the most incredible and hostile locations in the cosmos. You will discover the fundamental forces that shape reality in their most raw and powerful forms. What secrets are forged in the heart of a diamond rainstorm, and what kind of life could possibly thrive in an ocean locked under miles of ice? Which of these cosmic extremes do you think will challenge everything we know about survival? Our journey begins right next door with a world of pure fury. Venus presents itself as a brilliant jewel in our twilight sky, a beacon of beauty that masks a true inferno. This is not the gentle sister planet we might imagine. It is a place of relentless global violence. The surface temperature sits at a staggering 465 degrees Celsius, hot enough to liquefy lead and make zinc run like water. But the heat is only part of the horror. The air itself is a crushing ocean with a surface pressure 92 times greater than what we experience on Earth. It is the equivalent of being nearly a kilometer deep in our own ocean, a weight that would instantly collapse any submarine we could build. This immense pressure is the engine of a runaway greenhouse effect. Sunlight penetrates the thick atmosphere, but the heat it generates becomes trapped, unable to escape back into space. The planet has essentially baked itself into a permanent, self-sustaining furnace. High above this scorched landscape, the clouds offer no relief. They are not made of water vapor, but of corrosive sulfuric acid. These yellow clouds whip around the planet at hurricane speeds, creating a perpetual toxic rain. Yet in a final, cruel twist, this acid precipitation never reaches the ground. It simply evaporates in the searing heat below, rising back into the sky to begin the cycle of torment all over again. How did a world so similar to our own in size and location become such a perfectly designed hellscape? Leaving the scorching hell of Venus behind, we plunge into a deep freeze of stunning possibility. Far out in the solar system, orbiting the magnificent ringed planet Saturn, is a small, unassuming moon named Enceladus. This world of pure white ice, no larger than some countries on Earth, hides an astonishing secret. For decades, it appeared as little more than a frozen billiard ball, a silent and geologically dead orb. Then a spacecraft named Cassini flew by and witnessed the impossible. From the moon's south pole, colossal geysers were erupting into the void of space, creating magnificent plumes that reached thousands of kilometers high. These are not eruptions of lava or dust, but of pure water vapor and ice crystals, shooting from massive cracks in the icy shell nicknamed tiger stripes. It was a breathtaking sight, a frozen moon actively crying out into the cosmos. These plumes are a direct sample of what lies beneath. Enceladus is not a solid ball of ice. It has a global ocean of liquid water, a vast sea trapped between its rocky core and its icy outer crust. The gravitational tug of war with Saturn squeezes and flexes the moon's interior, generating enough heat to keep that enormous body of water from freezing solid. But the discovery grew even more profound. The plumes were found to be rich in organic molecules, the essential chemical building blocks for life as we know it. And then, scientists found the final, critical clue: tiny grains of rocky silica dust within the vapor. The only known process that creates particles of that specific size and composition is superheated water interacting with rock on the seafloor. This points strongly to the existence of hydrothermal vents, just like those found in the deepest, darkest parts of Earth's oceans. On our own planet, these vents are vibrant oases, teeming with life that thrives in total darkness, fueled not by sunlight but by chemical energy. So the question becomes unavoidable: On Enceladus, in that sunless subsurface sea, warmed by the moon's rocky heart and nourished by a constant rain of organics from above, could life have gained a foothold? This tiny, icy world has transformed from a frozen pebble into one of the most promising places to look for answers to one of humanity's oldest questions. But the cosmic extremes of pressure and hidden oceans are just the beginning. To find a place where matter itself is pushed to its absolute breaking point, we must look to the stellar ghosts left behind by supernova explosions. A neutron star is the collapsed core of a massive star that has ended its life in a cataclysmic blast. All that remains is a city-sized sphere, yet it contains more mass than our own sun. Picture the entire human race compressed into a single sugar cube. That barely begins to describe the density. A mere sugar cube's worth of neutron star material would weigh 1 billion tons on our planet, a weight so incomprehensible it defies all earthly logic. This creates a gravitational pull of almost unimaginable ferocity. If you were to drop a marshmallow from just 1 meter above its surface, it would impact with the energy of 1,000 hydrogen bombs. This gravity is so powerful it doesn't just pull on objects, it warps the very fabric of space and time around it. And some of these stellar corpses spin, becoming pulsars that sweep the universe with lighthouse-like beams of radiation. A millisecond pulsar rotates hundreds of times every second. Its razor-sharp beam of energy is so focused and deadly that it could slice a human body into its constituent atoms from thousands of kilometers away, disassembling you into a cloud of subatomic particles long before your remains ever reached the unimaginable surface below. Yet even the crushing density of a neutron star is not the end of our journey into extremes. We now venture into a realm of profound and silent darkness, into the space between the stars. Here, untethered from the warmth and light of any sun, drift the rogue planets. These are orphaned worlds, flung from their birth solar systems by gravitational chaos to wander the infinite interstellar void forever. Imagine a planet like Earth, but one where the sun has vanished for good. The sky is not black, but an utter and absolute emptiness devoid of any point of light. Day never comes. The surface temperature plummets to just a few dozen degrees above absolute zero, the theoretical point where all molecular motion ceases. It is a cold so deep it is difficult to comprehend, a freeze that would make the ice of Enceladus feel warm by comparison. The very atmosphere of such a world would have long ago collapsed, freezing solid and falling to the ground as a blanket of snow. Without a star to provide energy, the surface is a dead, frozen wasteland, locked in perpetual and unbreakable night. Yet even here there is a whisper of possibility. Deep within some of these wandering worlds, a radioactive heart may still beat. The slow, natural decay of heavy elements in the planet's core could generate a faint internal warmth. This residual heat, trapped by the incredible pressure of the overlying rock and ice, might be just enough to maintain a vast, global ocean of liquid water deep beneath the frozen surface. It is a haunting thought. A rogue planet could be a dark, frozen bullet on the outside while hiding a sunless sea within, a subterranean abyss warmed only by the planet's own dying embers. Could life persist in such a place, in total isolation, cut off from the rest of the universe for billions of years? If it does, it would be a life of silence and darkness, a biology fueled not by photosynthesis, but by the slow, geothermal breath of a world alone in the night. From the profound darkness between stars, we turn to a storm of unimaginable riches within our own solar system. Deep within the swirling blue atmospheres of Uranus and Neptune, a bizarre form of precipitation occurs. It does not rain water, but diamonds. The recipe for this cosmic treasure requires immense pressure, a key ingredient these ice giants possess in staggering amounts. Their atmospheres are thick with gases like methane, which is a simple molecule made of carbon and hydrogen. As you plunge thousands of kilometers downward, the pressure from the overlying layers of gas becomes so immense that it begins to tear the methane apart, squeezing the carbon atoms free. These free carbon atoms are then subjected to pressures millions of times greater than what we experience on Earth. Under this cosmic vise, the carbon atoms are forced into an incredibly tight crystalline structure. They become solid diamonds. These newly formed gems are heavy, too heavy to remain suspended. They begin to sink, pulled by the immense gravity deeper into the planet's interior. Scientists theorize that these diamonds do not fall as tiny, glittering specks. They likely form hailstones of solid diamond, perhaps growing to be millions of carats in weight as they descend through the dense atmospheric layers. It is a continuous, slow-motion avalanche of precious stones, falling toward a core we can barely comprehend. Researchers have recreated these extreme conditions in laboratories here on Earth, using powerful lasers to generate shock waves that compress carbon samples in an instant. The results confirm the theory, watching as ordinary carbon is indeed crushed into the structure of diamond. So on these distant, frozen worlds, the sky is perpetually filled with a rain of incalculable value, a storm of jewels falling endlessly into the eternal night of the planetary interior. The serene fall of diamond rain stands in stark contrast to the chaotic fury of our solar system's largest storm. For over 350 years, a colossal vortex has been raging in the atmosphere of Jupiter. This is the Great Red Spot, a storm so vast that our entire planet Earth could be swallowed within its swirling boundaries with room to spare. It is an anticyclonic storm, meaning it rotates in the opposite direction to the hurricanes we know on Earth, a high-pressure monster that towers 8 kilometers above the surrounding cloud tops. The winds that scream around its perimeter are a study in violence, reaching speeds in excess of 430 kilometers per hour, forces that would effortlessly shred any structure or craft we could conceive. What truly baffles scientists is not just its size or power, but its endurance. While even the largest terrestrial hurricanes dissipate after a few weeks, this Jovian behemoth has persisted for centuries. The secret to its longevity lies in its environment. Unlike Earth, Jupiter has no solid surface to create friction and sap a storm's energy. It is a world of pure, churning atmosphere, a fluid dynamics laboratory on a planetary scale. The storm acts like a giant wheel, feeding on the smaller storms and atmospheric currents that surround it, drawing energy from the planet's own internal heat to maintain its eternal spin. Yet one of its most defining features remains its greatest mystery, its deep, brick-red color. The leading theory suggests that chemical compounds from the lower atmosphere, perhaps phosphorus or complex hydrocarbons, are drawn up by the storm's powerful vertical winds. Once these compounds are exposed to the intense ultraviolet radiation from the sun high in the Jovian atmosphere, they may undergo a chemical change, creating a reddish chromophore that paints the storm. But no one knows for certain. This iconic spot is a permanent, violent, and enigmatic landmark, a swirling eye that has watched the solar system change for generations, all while keeping the secret of its own vivid hue. Jupiter's own moon Io presents a landscape of pure geological chaos. While its sibling Enceladus hides a quiet ocean, Io's interior is churned into a molten frenzy by an unrelenting gravitational tug of war. The immense gravity of Jupiter, amplified by the rhythmic pulls from the neighboring moons Europa and Ganymede, constantly squeezes and stretches Io's very structure. This gravitational kneading generates colossal tidal forces, creating so much internal friction that the moon's interior is kept perpetually molten. The result is the most volcanically active world we have ever observed. Hundreds of active volcanoes dot its mottled yellow and orange surface, continuously erupting and repaving the landscape. Plumes of sulfur and silicate rock can shoot hundreds of kilometers into the thin sky, while vast lakes of bubbling lava glow with an unearthly light. This constant eruption creates towering mountains, some taller than Mount Everest, which are then relentlessly buried under new layers of volcanic fallout. Yet the volcanic fury is only half the danger. Io orbits deep within Jupiter's powerful magnetic field, a vast, invisible bubble of radiation that traps charged particles from the Sun. This region, known as the magnetosphere, bathes the little moon in an intense, deadly shower of radiation. The surface radiation levels are thousands of times higher than a lethal dose for a human. An unshielded spacecraft in orbit around Io would have its electronics fried in a matter of hours. This creates a truly dual-layered hellscape, a world simultaneously being ripped apart from the inside by geological fire and bombarded from the outside by cosmic radiation. It is a stark reminder that the forces which create such spectacular vistas can also render them utterly uninhabitable. Saturn's largest moon, Titan, offers a landscape hauntingly familiar and yet utterly alien. It is the only other world in our solar system with stable liquids gracing its surface, a place of rivers, lakes, and vast seas, but do not expect to find water here. The bitter cold of -179 degrees Celsius ensures that water is frozen solid, harder than any rock on Earth. Instead, the fluid that carves the channels and fills the basins is liquid methane and ethane, hydrocarbons that flow like gasoline on this frigid world. Imagine standing on the shore of a methane lake, watching slow, lazy waves of liquid natural gas lap against a pebble shore of water ice. A thick, orange haze obscures the sky, a smog of complex organic molecules that rains down steadily, feeding the rivers and topping off the seas. This is a world built from the very chemicals we use for fuel on Earth, a whole planet drenched in them, and within this hydrocarbon soup a profound question arises. Could life exist here, not as we know it, but in a form so strange we can barely conceive of it? Life on Earth is based on water and uses water as its internal solvent. But what if a life form used liquid methane in the same way? Its cells would need to be built from different structures, perhaps from flexible molecules that can withstand the crushing cold. Its metabolism would be incredibly slow, its chemistry based on consuming other organic compounds that rain from the sky. It would be a life of patience, operating on timescales we might find difficult to recognize. Titan, with its thick atmosphere and active liquid cycle, presents us with a second genesis of life, a parallel biology that could be thriving in the shadows, a testament to the universe's relentless and inventive drive to create. The silent, patient chemistry of Titan stands in stark opposition to the ultimate cosmic violence of a supernova. This is the death scream of a star, a final, defiant act of self-immolation that seeds the universe with the very stuff of creation. When a star many times more massive than our Sun exhausts its nuclear fuel, the delicate balance of its life is shattered. For millions of years, the outward push of fusion energy fought a steady war against the star's own immense gravity. When that energy stops, gravity wins in an instant. The star's core collapses, falling inward at a quarter of the speed of light, and then rebounds in a cataclysmic shockwave that blasts the entire star apart. For a few brief, glorious weeks, a single supernova can outshine an entire galaxy of 100 billion stars. The heart of this explosion is a crucible of almost inconceivable extremes. Temperatures soar to billions of degrees, and pressures reach levels that dwarf anything inside a neutron star. It is within this fleeting, unimaginable inferno that the universe forges the elements of life and civilization. All the iron in your blood, the calcium in your bones, and the oxygen you breathe were cooked inside a long-dead star. But the supernova provides the final, essential alchemy. It is the only environment violent enough to create the heaviest elements like gold, silver, and uranium. Every piece of jewelry, every ounce of precious metal, every radioactive power source was born in this fleeting moment of stellar death. The explosion does not just create, it also scatters. The shockwave from the dying star races outwards for light years, a colossal wall of energy and newly forged elements that slams into the calm, cold clouds of interstellar gas. This violent compression is the trigger for new star birth. It squeezes pockets of gas until they ignite under their own weight, giving rise to a new generation of stars and with them new planets. Our own solar system is the child of such an event. The dust cloud that coalesced into our sun and the Earth was enriched by the debris from ancient supernova that exploded billions of years before. We are quite literally the children of stardust, assembled from the ashes of giants that died so that we could one day exist. The serene creation of new solar systems from supernova debris gives way to a more personal and violent form of stellar suicide. Wolf-Rayet stars are the final, furious death throes of the most massive stars in the universe. Imagine a star so colossal it has burned through its nuclear fuel with reckless speed, reaching the end of its life in just a few million years. Now, in its final act, it begins to tear itself apart from the inside out. The star's core becomes so intensely hot that it radiates a phenomenal amount of energy, which pushes the star's own outer layers away with the force of a continuous explosion. This creates a stellar wind of unimaginable ferocity, a supersonic gale of superheated gas screaming outward at speeds of up to 6 million miles per hour. The force of this wind is so immense that the star effectively evaporates, shedding an amount of material equivalent to the entire mass of our Earth every single year. This is not a gentle shedding of layers, but a violent, sustained self-destruction that strips the star down to its bare, blazing core. As these hurricane-force winds blast into the surrounding space, they collide with slower-moving gas the star ejected in its earlier life. This collision creates spectacular, glowing nebulae, intricate shrouds of energized gas that look like cosmic fingerprints on the sky. The exposed core of the star, now naked and visible, burns at a temperature of over 200,000 degrees Celsius, shining with a brilliant, harsh blue-white light that outshines our own sun by hundreds of thousands of times. A Wolf-Rayet star is a star flaying itself alive, offering us a terrifyingly beautiful glimpse into the heart of a stellar furnace in its final, defiant moments before the inevitable supernova. Even the self-destructive fury of a Wolf-Rayet star is a mere prelude to the universe's final and most absolute extreme. A black hole represents a point where gravity has won the ultimate victory, crushing matter into a region of infinite density known as a singularity. The boundary surrounding this point of no return is called the event horizon, a one-way membrane in the fabric of space. Crossing this threshold means that not even light, the fastest thing in the cosmos, can ever escape. The laws of physics as we know them simply break down, but the journey toward this oblivion would be a terrifyingly physical experience. As you fell toward a stellar mass black hole, the difference in gravitational pull between your head and your feet would become immense. Your body would be stretched into a long, thin stream of atoms, a process gruesomely nicknamed spaghettification. You would literally be pulled apart into a single file line of fundamental particles spiraling into the darkness. Yet not all black holes are these relatively small stellar destroyers. At the heart of nearly every large galaxy, including our own Milky Way, lurks a supermassive black hole. Our local giant, Sagittarius A star, weighs in at 4 million times the mass of our Sun. These colossal entities are not the voracious vacuum cleaners of popular imagination. Their event horizons are so vast that you could cross them without immediately noticing anything strange. Their true power lies in their gravitational influence over an entire galactic neighborhood. They govern the orbits of millions of stars, whipping them around at incredible speeds. The energy released as gas and dust spiral into their grasp can ignite quasars, the brightest objects in the universe, outshining all the stars in their host galaxy combined. A supermassive black hole is the silent, dark heart of a galaxy, a gravitational anchor whose presence dictates the structure and destiny of billions of stars, including our own. While black holes anchor galaxies with their immense gravity, they also possess the power to violently expel stars into the eternal night. Hypervelocity stars are the ultimate cosmic runaways, flung from their home galaxies at speeds exceeding 1 million miles per hour. These stellar projectiles begin their journey in the chaotic core of a galaxy, where a binary star system wanders too close to the central supermassive black hole. The black hole's overwhelming gravity captures one star, pulling it into a tight orbit while simultaneously slingshotting its companion outward with unimaginable force. It is a gravitational assist of terrifying power, a cosmic crack of the whip that sends the star racing toward the edge of the galaxy and beyond. Once free, it embarks on a solitary journey through the incomprehensible emptiness of intergalactic space. Its trajectory is a one-way ticket into the void, a path from which there is no return. Imagine a star like our own sun, but traveling alone through a darkness so profound that the entire Milky Way would eventually shrink to a faint, hazy smudge of light behind it. This star will never again be part of a galaxy. It will never host a family of planets, for any worlds it once held would have been torn away or vaporized during its violent ejection. It is a stellar orphan, destined to burn its nuclear fuel in utter isolation, its light a lonely beacon in a sea of nothingness. When it finally dies, its corpse will continue this endless drift, a cold, dark remnant wandering between the islands of light we call galaxies for all of eternity. The silent drift of hypervelocity stars gives way to a world forged in fire. Orbiting perilously close to its sun-like star is a super-Earth named 55 Cancri e, a planet that defies every notion of a habitable world. A single year here, one complete orbit, passes in a mere 18 hours. This blistering speed is a direct consequence of its intimate dance with its star, a proximity so extreme that the planet is likely tidally locked. One hemisphere faces the star in perpetual, scorching daylight, while the other is locked in an endless, though not much cooler, night. The surface temperature on the day side soars to an unimaginable 2,700 degrees Celsius, hot enough to vaporize iron and melt tungsten, the metal with the highest melting point on Earth. This inferno ensures the planet's surface is not solid rock, but a global, roiling ocean of molten lava, hundreds of kilometers deep. The entire landscape is a single, incandescent sea of liquid stone, churned by unimaginable tides and superheated storms. Yet the planet's composition holds an even more startling secret. 55 Cancri e is believed to be a carbon-rich world, a place where oxygen is scarce and carbon is the dominant element. Under the immense pressure from the overlying ocean of lava and the planet's own powerful gravity, that carbon could be undergoing a radical transformation. Deep within this hellish world, the carbon atoms may be compressed into a crystalline structure, forming a vast, solid core of diamond. Picture a world with a heart of pure gemstone, a glittering interior shielded from the surface furnace by a planetary mantle of liquid rock. This is not a gentle diamond rain, but an entire geological foundation of precious crystal. 55 Cancri e presents a paradox of cosmic extremes, a world of incalculable mineral wealth, eternally drowning in a global ocean of its own molten crust. Tidal locking creates a world of permanent duality, and the exoplanet TRAPPIST-1e is a perfect example of this cosmic standoff. Orbiting an ultra-cool red dwarf star, this planet is so close that its year is just a handful of Earth days. The star's gravity has long since seized the planet's rotation, forcing one hemisphere into an unblinking stare at its dim sun. The day side is a scorched wasteland perpetually cooked by stellar radiation. On the opposite side, the night hemisphere exists in a deep freeze, a darkness so profound and permanent that its very atmosphere might have collapsed, frozen solid onto the ground. The true drama unfolds in the thin, crepuscular band that separates these two extremes, the Terminator line. Here, in a perpetual state of twilight, temperatures could theoretically be just right for liquid water to exist on the surface. This ribbon of moderate climate has sparked the imagination of scientists, a potential oasis wrapped around a world of fire and ice. Yet this twilight zone would be anything but tranquil. The colossal temperature difference between the two sides would fuel planet-wide weather systems of unimaginable ferocity. Supersonic winds would scream from the scorching high pressure of the day side toward the freezing low pressure of the night side, an endless torrent of atmospheric violence. Any water in that habitable band would be lashed by eternal storms, a turbulent mixing zone where the planet's two identities violently collide. Life, if it could cling to existence here, would face a world of horizontal sunsets and unending gales, a fragile existence on the razor's edge between a fiery death and a frozen one. Even the burning twilight of tidally locked worlds cannot compare to the profound chill of the cosmic deep freeze. The Boomerang Nebula holds the title as the coldest known natural place in the universe, a region of space where the temperature plummets to just 1 degree above absolute zero. This is a mere single degree warmer than the theoretical point where all atomic motion ceases entirely. To understand this cold, consider that the background temperature of empty space, the faint afterglow of the Big Bang, is a relatively balmy 2.7 Kelvin. The Boomerang Nebula is significantly colder than the void itself. This incredible chill is the work of a dying star at the nebula's heart, a red giant in its final death throes. This star is not exploding, but rather evaporating at a phenomenal rate. It is expelling its own outer layers in a supersonic wind so fast and so voluminous that the gas expands and cools in the same way your refrigerator works. When gas expands rapidly, its particles spread out and lose energy, causing the temperature to drop precipitously. The star is essentially blowing itself apart with such force that it creates a cosmic refrigeration unit, a natural deep freeze on an interstellar scale. The result is a magnificent bow-tie-shaped cloud of gas and dust that spans over 3 light years. Within this cloud, even the faintest whisper of heat has been stolen away, creating a pocket of the universe where physics operates at its most frigid extreme. It is a stunning paradox, a place of stellar death that has become a monument to absolute cold. Yet the crushing embrace of a neutron star can grow even more terrifying. Some of these stellar corpses are born spinning with a ferocious magnetic field, transforming them into magnetars, the true monsters of the cosmos. The power of their magnetism defies all human experience. Our planet is protected by a magnetic field that guides compasses and creates the aurora. A magnetar's field is a quadrillion times stronger. To find a force of this magnitude, you would have to take 1,000 trillion of Earth's magnets and combine them into one. This field is so overwhelmingly powerful it warps reality on a subatomic scale. The magnetic force is strong enough to distort the very shape of atoms, stretching them from their familiar spheres into long, thin, needle-like rods. Any object that ventured too close would have its atomic structure utterly dismantled. The magnetic field itself is lethal from a distance of thousands of kilometers, capable of wiping the data from every credit card on Earth, erasing the magnetic strip in an instant. But the true danger lies in the star's crust. This surface is not a smooth sphere, but a solid, immensely dense shell of iron, under unimaginable stress from the magnetic field twisting within. Occasionally, this crust can crack. These are starquakes, seismic events on a scale that makes our planet's greatest earthquakes feel like a gentle tremor. When the crust of a magnetar fractures, it releases a cataclysmic burst of energy. In a mere tenth of a second, a single starquake can unleash more energy than our sun will emit over the next 100,000 years. This energy erupts as a flash of gamma rays and X-rays, a death beam of pure radiation that can race across the galaxy. In 2004, a magnetar halfway across the Milky Way had a starquake so violent that its radiation pulse, though harmless by the time it reached us, was powerful enough to compress Earth's upper atmosphere and briefly disrupt long-range radio communications across the globe. It was a stark reminder that we live in a neighborhood where a single crack in a star's surface, from an object we cannot even see, can momentarily reach out and touch our world. The silent, frigid death of the Boomerang Nebula gives way to a world of screaming, horizontal violence. HD 189733b is a gas giant that glows with a deep, deceptive azure blue, a color that evokes the tranquil oceans of Earth. This resemblance is a cosmic lie. The planet's beautiful hue comes not from water, but from a high-altitude haze of silicate particles, the very same material that makes up glass. These particles are not drifting calmly. They are caught in a perpetual, supersonic hurricane. Winds scream across this world at a staggering 7,000 kilometers per hour, a speed that makes the most violent terrestrial tornadoes seem like a gentle breeze. At these velocities, the sound barrier is not just broken, it is utterly irrelevant. The silicate particles in the atmosphere are superheated by the intense, proximate glare of the planet's star. They condense into droplets of molten glass, which are then seized by the relentless atmospheric currents. This is not a gentle rain. It is a permanent, planet-wide sandblasting of liquid glass propelled sideways at bullet-like speeds. The planet is so close to its star that a single year passes in just over 2 Earth days, and this intimate orbit locks it in a gravitational embrace that superheats its atmosphere and drives these phenomenal winds. Any probe or ship that dared to enter this maelstrom would be scoured away in an instant, its metal hull etched and shattered by a billion microscopic projectiles. This is a world where the sky itself is a weapon, a beautiful blue sphere hiding a storm of endless, razored fury. The glass storms of alien worlds eventually quiet, and even the most brilliant stars must face their final days. For a star like our own Sun, this death is not a violent supernova, but a more poetic and gradual transformation. It begins when the star exhausts the hydrogen fuel in its core, swelling into a red giant that could engulf the inner planets. After this phase of expansion, the star can no longer hold onto its outer layers. It gently sheds them, not in an explosion, but in a slow, magnificent exhalation that expands into space for thousands of years. This is the birth of a planetary nebula, one of the most beautiful and fleeting sights in the cosmos. These intricate shells of glowing gas are painted across the void in ethereal hues of blue, green, and red, illuminated by the intense ultraviolet light from the tiny, hot core left behind. The name itself is a misnomer from early astronomy, when their round shapes resembled distant planets through primitive telescopes. They have nothing to do with planets, but are instead the final, glowing shrouds of dying stars. And they are tragically ephemeral. A planetary nebula shines for a mere 10,000 years, a blink of an eye on the cosmic timescale, before its gas disperses and fades into the darkness of interstellar space. All that remains is the stellar corpse, a white dwarf. This is the star's exposed core, an Earth-sized sphere containing nearly all the mass of the original star. A single teaspoon of white dwarf material would weigh as much as an elephant on our planet. This incredible density is the final state of matter, supported not by fusion, but by a quantum mechanical force called electron degeneracy pressure. The white dwarf has no internal energy source left. It is a fading ember, a diamond-like cinder that will slowly cool over billions of years, eventually becoming a cold, black dwarf, a dark crystal drifting in the eternal night. These cosmic graveyards are not just endings, however. The material expelled to create the planetary nebula is rich in heavy elements forged during the star's life. This stardust, seeded across the galaxy, will one day be incorporated into new stars, new planets, and perhaps new life. Our own Sun will one day undergo this very process, its outer layers forming a beautiful, glowing bubble in the solar system, while its heart becomes a dense, Earth-sized diamond in the dark. The serene death of a star is a quiet affair compared to the endless atmospheric war on HDP 7b. This distant gas giant presents a face of pure, unrelenting electrical fury. Tidally locked to its star, the planet is a study in violent contrasts. One hemisphere is a permanent inferno, superheated to over 2,500 degrees Celsius, while the darker night side is comparatively cooler, though still hot enough to melt steel. This staggering temperature difference creates a relentless, planet-spanning engine for weather. The extreme heat on the day side causes atmosphere to rise violently, rushing toward the night side in a supersonic torrent. There it cools and plunges back toward the day side, completing a cycle of unimaginable atmospheric violence. Within this churning maelstrom, clouds form, but they are not made of water. At these temperatures, the clouds are likely composed of corundum, the same mineral that forms rubies and sapphires on Earth. These mineral particles, colliding and swirling in the hurricane-force winds, generate colossal amounts of static electricity. The result is a perpetual global lightning storm. Each flash is not a brief streak in the sky, but a cataclysmic event in itself. Scientists believe these discharges could be thousands of times more powerful than the most intense lightning ever recorded on our own planet. Imagine a world where the sky is never dark, but constantly illuminated by a silent, strobing light show of apocalyptic proportions, where the very clouds rain molten gemstones and the air crackles with energy capable of vaporizing continents. This is not a transient thunderstorm, it is the planet's permanent state of being, a climate of pure electrical chaos. Gliese 436b defies every logical expectation for a world. This Neptune-sized exoplanet orbits so close to its star that its surface temperature scorches at 440 degrees Celsius, hot enough to melt lead. Yet, astonishingly, it is a world covered in ice. This is not a paradox, but a brutal demonstration of overwhelming force. The planet's immense gravity, generated by a mass 22 times greater than Earth's, creates a pressure so profound it reshapes reality itself. Here, ordinary water is compressed into an exotic state of matter known as Ice 7. Unlike the fluffy ice in your freezer, which forms at low pressures, Ice 7 is a cubic crystalline structure that only exists under pressures hundreds of thousands of times greater than our atmosphere. The gravitational force pressing down on the water molecules is so immense that it locks them into a rigid, solid lattice, even while the external temperature is trying desperately to tear them apart into vapor. The ice does not melt because it is not allowed to. The pressure simply will not let the molecules move freely enough to become liquid. So the planet presents a truly alien landscape, a globe of burning ice where solid water glows with a dull red heat, steadfastly frozen in a perpetual fiery blizzard. It is a world where two fundamental forces, heat and pressure, are locked in a stalemate, creating a substance that is both solid and searing, a monument to the universe's capacity for contradiction. Some of the universe's most destructive environments are also its most creative engines. At the heart of certain galaxies, a supermassive black hole does not lie dormant. Instead, it feasts, transforming its immediate surroundings into a maelstrom of incandescent fury known as an active galactic nucleus. This is a place where gravity is not just a force but a voracious appetite. Vast rivers of gas, dust, and even entire stars are drawn into an inexorable spiral toward the event horizon. This doomed material does not fall in directly, but piles up into a colossal structure called an accretion disk, a whirlpool of matter so vast it could encompass our entire solar system. Within this disk, particles rub against each other at fantastic speeds, generating temperatures of millions of degrees and causing the entire disk to glow with the intensity of billions of stars. This is the power source for the most luminous sustained objects in the cosmos. But the true spectacle lies at the black hole's poles. Along the axis of its rotation, the black hole's immense magnetic fields and ferocious spin act like a cosmic railgun, channeling some of the infalling material and accelerating it to nearly the speed of light. These are the relativistic jets, twin beams of pure energy and particles that blast out from the galactic core, punching straight through the galaxy itself. They can extend for hundreds of thousands of light years, far beyond the visible boundaries of their home galaxy, sculpting the intergalactic medium and triggering or quenching the birth of new stars in their path. An active galactic nucleus is the ultimate cosmic paradox, a system of apocalyptic destruction that simultaneously forges the future of its galactic neighborhood, a cannibal whose feast lights up the universe. These jets are not gentle streams but colossal, focused beams of pure destruction. They are composed of plasma, a superheated state of matter where atoms are torn apart into a seething soup of electrons and atomic nuclei. This material is accelerated to relativistic speeds, meaning it travels at a significant fraction of the speed of light. As these jets erupt from the poles of the supermassive black hole, they do not simply fade into the void. They slam directly into the calm, cold clouds of gas and dust that fill interstellar space. The collision is catastrophically violent. The energy transfer is so immense that it heats this interstellar material to millions of degrees in an instant, causing it to glow with intense X-rays. This process effectively acts as a cosmic blender, churning and agitating entire regions of a galaxy that would otherwise be the quiet nurseries for new stars. In these nurseries, gravity slowly pulls gas together until it collapses and ignites into a new sun. But when a quasar jet plows through, it does the exact opposite. The incredible heat and turbulence prevent the gas from ever cooling down and condensing. It keeps the material too hot and too energetic to coalesce under its own gravity. The jet essentially sterilizes vast tracts of its host galaxy, shutting down star formation for light years around. This creates a powerful feedback loop where the very engine that lights up the galaxy also dictates its future structure by carving out immense, empty bubbles where no new stars will ever be born. It is a stunning display of cosmic power where creation and destruction are two sides of the same violent coin. Beyond the last planets, far past the wandering rogue worlds, lies a realm of pure stillness. The Oort cloud is a ghostly shell of icy fragments enveloping our entire solar system, a cosmic deep freeze so distant that the sun is just a particularly bright star in an otherwise ordinary sky. This is not a flat disk like the asteroid belt, but a vast spherical cloud extending nearly a light year into the void. Out here, temperatures hover just a few degrees above absolute zero, a chill so profound that even the air we breathe would freeze into a solid, brittle rock. The orbits of these icy bodies are measured not in years but in millennia. A single, slow journey around the sun can take millions of Earth years, a glacial pace that defies human comprehension. This is the graveyard of our solar system's construction, a frozen archive containing trillions of pristine planetary building blocks that never coalesced into a world. They are the leftover raw materials from the dawn of our sun, preserved in a perfect state of suspended animation for billions of years. Yet this graveyard is also a nursery for celestial wanderers. Occasionally, the gentle gravitational nudge from a passing star or the tidal pull of the galaxy itself will dislodge one of these icy fossils. It begins a fall inward, a multi-million-year plunge toward the warmth of the inner solar system. As it approaches the sun, the ice heats up, transforming directly from a solid into a glowing gas, sprouting a magnificent tail that streams across the night sky. We know these visitors as long-period comets, brilliant but fleeting messengers from the silent, frozen edge of our own celestial home. This celestial thievery unfolds in a binary star system, a cosmic dance between two stellar partners. One star is a dense corpse, a white dwarf or neutron star, while its companion is a bloated, aging giant. The immense gravity of the dead star acts as a relentless siphon, pulling streams of hydrogen gas directly from the atmosphere of its living neighbor. This stolen material does not fall directly onto the surface. Instead, it spirals inward, forming a vast, flat whirlpool of superheated gas known as an accretion disk. Friction within this disk heats the gas to millions of degrees, causing it to glow with the ferocious intensity of a miniature sun. For a time, this process creates a delicate, violent balance, a symbiotic relationship built on theft. The dense stellar vampire feeds steadily, its accretion disk blazing in the darkness as it consumes its partner's very substance. This stable feeding, however, cannot last forever. On the surface of a white dwarf, the stolen hydrogen accumulates under tremendous pressure and heat. Eventually, it reaches a critical flashpoint, igniting a runaway thermonuclear explosion. This is a nova, a stellar detonation that can suddenly increase the system's brightness 10,000-fold. The star appears to flare to life in the sky, a new star where none was visible before. Unlike a supernova, a nova does not destroy the white dwarf. It merely blasts the accumulated stolen material back into space in a brilliant shell of expanding gas. After the firestorm subsides, the theft begins again, the cycle of accumulation and explosion repeating over millennia. It is a slow, cosmic feast, punctuated by bursts of unimaginable violence, where one star slowly consumes the other to briefly reclaim a ghost of its former glory. The scale of our own sun is dwarfed by the true titans of the stellar world. Hypergiant stars like VY Canis Majoris are cosmic leviathans of such immense proportion they defy all reasonable sense of scale. If you were to place this single star at the center of our own solar system, its searing surface would not stop at the orbit of Earth or even Mars. It would extend outward, swallowing the asteroid belt and the planet Jupiter whole. Only at the orbit of Saturn, nearly 900 million miles from the center, would you finally escape its fiery outer layers. Our entire inner solar system would be vaporized within its atmosphere. These stars are not just large, they are profoundly unstable. Their immense gravity struggles to hold onto their own outer layers, leading to a constant, catastrophic shedding of mass. VY Canis Majoris is coughing vast clouds of dust and gas into space, expelling an amount of material equivalent to the mass of 30 Earths every single year. This is not a gentle stellar wind, but a continuous eruption, a star tearing itself apart simply to exist. Such a violent existence comes at a cost. Burning through their nuclear fuel at a frantic pace, these hypergiants live fast and die young. Their entire life cycle, from birth to death, spans only a few million years, a mere blink in the multi-billion-year life of a star like our Sun. Their inevitable end is as grand as their size. They are destined for the most spectacular of cosmic deaths, a supernova so powerful it is often classified as a hypernova. This final detonation will be so unimaginably violent that it will outshine entire galaxies, forging the heaviest elements in the universe and scattering them across space to seed future generations of stars and planets. These stellar titans live a short, brilliant, and turbulent life, all to die in a blaze of glory that fundamentally shapes the cosmos around them. These celestial misfits are the universe's failed stars. Brown dwarfs are cosmic in-betweeners, objects too massive to be called planets, yet not massive enough to ignite the sustained hydrogen fusion that defines a true star. They are born from collapsing clouds of gas just like stars, but they simply lack the heft to turn on their main power source. Their core pressures, while immense, never reach the critical threshold to fuse hydrogen into helium. Instead, they glow with a dull, residual heat left over from their violent formation, and for a brief period they can burn a trace of deuterium, a heavy isotope of hydrogen. This feeble internal energy is not enough to fight off the inevitable, relentless cooling. A brown dwarf's entire life is a long, slow fade from a dim red ember to a cold, invisible cinder. Their atmospheres are where physics becomes truly bizarre. As you descend through their cloudy layers, the temperature and pressure soar to extremes that liquefy minerals. In the cooler, Y-type brown dwarfs, the upper atmosphere might be cool enough for clouds of water vapor to form, but descend further and you would find clouds of liquid iron and silicate dust. This is not a gentle mist. It is a raging, turbulent sky where droplets of molten metal and grains of hot sand are whipped by ferocious winds. Imagine a world where the rain is literally made of liquid iron, a downpour that would etch and melt anything it touched. These strange objects blur the line between star and planet so completely that they challenge our very definitions, occupying a mysterious middle ground where the rules of stellar physics end and the rules of planetary weather begin. Reaching the final frontier of velocity means confronting a universe that warps and twists around you. This is the relativistic realm, an environment defined not by heat or pressure, but by pure, unadulterated speed. According to Einstein's theory of relativity, as you approach the speed of light, the very fabric of reality begins to behave in ways that defy common sense. Two profound effects take hold: time dilation and length contraction. Time dilation means that time itself slows down for the traveler moving at a relativistic pace. Imagine a pair of twins. One stays on Earth while the other embarks on a journey to a star 4 light-years away in a ship traveling at 99% of light speed. For the twin on Earth, the round trip takes a little over 8 years. They live their life, they grow older. But for the twin on the ship, the experience is radically different. Due to time dilation, their clock, their heartbeat, their very perception of time slows down dramatically. For them, the entire journey might only take a few months. They would return to an Earth where their twin sibling is years older than they are. The universe itself has become a time machine. Simultaneously, length contraction warps their perception of space. The distance to the star, which seems immense from Earth, would appear to shrink for the traveler. That 4 light-year journey would feel much shorter because the space in front of their ship is physically contracting, compressing like the bellows of an accordion. This is not an illusion. It is a fundamental reshaping of reality from their unique frame of reference. For the traveler, the universe ahead becomes a tunnel of distorted starlight, while the universe behind recedes into a deep red haze. The environment outside their vessel is one of extreme, high-energy radiation, as even the faintest wisps of interstellar dust would strike the hull with the force of a nuclear explosion. A journey at such velocities would subject any craft to a continuous, deadly barrage, making the void of space itself a hostile and unforgiving medium. To travel at the speed of light is to enter a state where the universe's most basic rules of space and time are pushed to their absolute breaking point. But all these cosmic extremes, from stellar titans to frozen wanderers, trace their origin back to a single, definitive moment of creation. To find the most extreme environment of all, we must journey to the very beginning of time itself. In the first fleeting instance after the Big Bang, the entire observable universe was compressed into a space smaller than a single atom. This was a reality of almost incomprehensible heat and density, a seething, chaotic soup of pure energy where temperatures soared to over 1 quintillion degrees. The fundamental forces that govern our reality, gravity, electromagnetism, and the nuclear forces, were not separate entities but fused into a single, unified power. In this primordial inferno, matter as we know it could not exist. Particles and antiparticles spontaneously blinked into and out of existence, annihilating each other in flashes of energy, all within a sea of searing radiation. It was a state of being so alien that our current laws of physics cannot fully describe it. As the universe expanded and cooled at a fantastic rate, a critical transition occurred. The unified force began to split, and in that separation, the building blocks of reality were cast. Within the first second, quarks and gluons coalesced from the energy sea to form the first protons and neutrons. For the next few minutes, the entire universe acted as a single, colossal nuclear furnace. This period, known as Big Bang nucleosynthesis, was a brief window where protons and neutrons collided and fused, forging the nuclei of the lightest elements, hydrogen, helium, and a trace amount of lithium. Then, the expansion diluted the cosmic soup too much, and this universal fusion shut down. For nearly 400,000 years, the universe remained a hot, opaque fog of ionized gas, too hot for electrons to be captured by these atomic nuclei. Light was trapped, bouncing endlessly between charged particles. Finally, the universe cooled enough for a momentous event, recombination. Electrons were snatched from the plasma to orbit atomic nuclei, forming the first stable neutral atoms. In that instant, the cosmic fog lifted, and the universe became transparent, releasing the primordial light that we now observe as the cosmic microwave background radiation. Every galaxy, every star, every planet, and every one of us was ultimately forged in that unimaginable heat. The entire cosmic story, from the first atom to the most complex life, began in that ultimate crucible of extremes. From the ultimate crucible of the Big Bang to the silent drift of rogue planets, our journey reveals a cosmos of breathtaking contrasts. These 28 environments are not just curiosities, they are fundamental expressions of the laws that govern all of reality. Each one, from the crushing pressure that forges diamond rain to the relativistic jets that sculpt entire galaxies, pushes matter and energy to their absolute limits. By studying these cosmic extremes, we are not merely cataloging distant wonders. We are stress-testing our understanding of physics itself, learning how gravity, heat, and force behave when there are no earthly constraints. This exploration ultimately turns inward, forcing us to reflect on our own delicate existence. We live on a fragile world suspended between fire and ice, a temporary oasis of calm in a universe dominated by unimaginable violence and profound stillness. Our planet is a rare sanctuary, a testament to the precise and delicate balance that makes our lives possible. Every one of these distant, hostile realms tells us something profound about our own origins and our place in the vast cosmic story. We want to hear which of these facts reshaped your view of the universe. Was it the endless lightning storms of HTP 7b, the burning ice of Gliese 436b, or the silent, sunless oceans of a rogue planet that captured your imagination the most? Share your thoughts in the comments below, and if you enjoyed this tour of cosmic extremes, subscribe for more journeys into the deepest mysteries of space. Surviving these cosmic hellscapes demands technologies that seem ripped from science fiction. To even glimpse the surface of Venus, a lander must be a fortress, built from titanium alloys and sophisticated ceramics capable of withstanding both the crushing pressure and acid-laced atmosphere. For a world like Io, the challenge is not just heat but radiation. Any robotic explorer would need a vault-like shield of lead and water, a heavy suit of armor just to prevent its computer brain from being fried by Jupiter's relentless particle storms. And to dive into the hypothesized oceans of Enceladus, we would need a cryobot, a thermal drill that could melt its way through miles of ice, followed by an autonomous submarine built to navigate a sunless sea under immense pressure, all while communicating its findings back to the surface through a shifting, frozen ceiling. These are not mere upgrades to our current rovers, they are entirely new classes of machine, engineered to endure conditions we can only simulate in our most punishing laboratories. Yet, the life we might find with such technology could be just as radical. On Earth, we have discovered extremophiles thriving in boiling acid, in the heart of nuclear reactors, and in the crushing depths of ocean trenches. This tells us that life is not a delicate anomaly but a stubborn force. Within the subsurface ocean of Enceladus, life would not bask in sunlight but in chemical energy, perhaps clustered around hydrothermal vents, forming vast ecosystems of silent, slow-moving creatures in the eternal dark. Even more bizarrely, life might not be confined to planetary surfaces at all. The dense, turbulent atmospheres of gas giants like Jupiter could, in theory, host a unique form of aerial life. Picture balloon-like organisms, vast floating mats of microbes that rise and fall through the cloud layers, harvesting chemical nutrients and using the planet's fierce winds to travel. Their entire world would be a sky, a perpetual journey through layers of ammonia and water ice, never touching a solid surface. This expands the very definition of a habitable zone from a narrow band around a star to any environment, anywhere, that possesses a gradient of energy and a liquid medium. The universe's most hostile corners may not be barren at all, but quietly, patiently, teeming with forms of existence we are only beginning to dream of.